Hello viewers, thank you for coming back. We will continue with our next hands-on tutorial, which is part of the certification course hands-on. The certification course is designing and implementing a data science solution on Azure. We'll be continuing the next hands-on of using automated machine learning from SDK. So we'll be utilizing the machine learning SDK provided by Azure and using the automated machine learning SDK to run our experiment. So I have opened this hands-on here in this tab. So here if you see, determining the right algorithm and pre-processing transformation for model training can involve a lot of guesswork and experimentation, right? When we are trying to do transformation of the data, doing pre-processing, running the right algorithm, all these involves a lot of trial and error from our end. Okay, so what we will do in this exercise, we will use automated machine learning to determine the optimal algorithm which will give us accurate and non-biased data or less biased model and pre-processing steps for model by performing multiple trainings which will be run in parallel. Okay, so we'll be doing parallel runs with different algorithms and pre-processing steps. Okay, different hyper parameter tuning as well. Okay, and based on that we'll try to find out which algorithm makes best suits our model. Okay, and gives the best accuracy basically. So before we start, the prerequisite is to create a Azure machine learning workspace within your resource group and then clone a Jupyter notebook specific to your hands-on. I have covered all this in my previous video. You can click on the icon and then go to that particular video and complete creating the Azure machine learning workspace, and then come back to this hands-on. Okay, so this notebook I have already opened and I have kept my compute resource which is created in workspace as running. Okay, and if you can see, this is my compute instance up and running. Okay, if you want to see it from here, you can go to the home page and you can always check the compute instance here. So this is my compute instance already running. Okay, now let's start. So there are many kinds of machine learning algorithms we can use to train our model. Sometimes it's not easy to determine which one will give us the optimal effective performance, right? So we try with different algorithms and different set of pre-processing of the data to get the required prediction. Okay, now we can additionally you can significantly affect the predictive performance of a model by pre-processing the training data. Okay, so in the training data that we will have, we can pre-process so that it will give more accurate results and more accurate model. Okay, so using techniques such as normalization, missing feature imputation and others, these are kind of different pre-processing steps we can perform on our training data. Okay, so that our model will be more accurate and will be able to cater to the scenarios where we have missing values of different variations in the data, right? In your quest to find the best model for your requirement. Okay, so to find out the best model, we can perform these pre-processing steps as well, normalization and all these things. Okay, You may need to try many combination of algorithm and pre-processing transformation, which takes a lot of time and compute resources. Okay, so all these different algorithms and pre-processing step that we are going to try is going to take a lot of time, right? And also the compute resources. What we'll be doing, we'll be taking help of Azure Machine Learning, okay, to automate those uh, steps, pre-processing steps, checking of the different algorithms, right? Selecting different algorithms to train our model, and also in real time, it will be comparing the models, which model has performed better and for which algorithm and pre-processing steps. That will be done through visual interface, which is Azure Machine Learning Studio that we have opened here, right? Or SDK to leverage this capability. So this step is for SDK. It gives us better control over the settings for the automated machine learning. Of course, there are pros and cons for both of these options. Azure Machine Learning Studio gives you more easier interface to use, but then you'll have less control over it. If you want to go into a granular level for doing all kinds of tweaking to your experiment, machine learning experiment, but SDK will not give you much of a visual interface, but you'll have a more control onto what you want to do with your machine learning experiment. Okay. So before we start, we have to check which Azure machine learning model the package. I mean this Azure machine learning package is installed or not. Okay. So for that we can run this cell, and it's going to show us whether this Azure machine learning model is installed. Yeah, this is installed, and you can see the version of the Azure machine learning training AutoML SDK. Okay, this is provided by Microsoft Corporation. Here you can see all these different summary as well. This requires ensure ML runtime, dataset runtime, AutoML core component, train AutoML client, training AutoML runtime, right? So these are all different packages as well. Okay, and it's part of the Python 3.6 Anaconda environment package. Okay, now connect to your workspace. So to run our automated machine learning, right, experiment using the SDK, first we need to connect to our workspace and create all the artifacts related to our experiments. Those artifacts would be the Python script with all the test training model, algorithm information, compute resources, cluster information. All those will be required, right, to be created within our cluster and then run our experiment. So first of all, let's connect to our workspace. It will give you the Azure ML version and the workspace name, which is ML workspace that I have created. This I have covered like how to create a workspace within Azure Machine Learning. So that you can refer in the same video that I am referring. Okay. Next, we need to prepare the data. You do not need to create a training script for automated machine learning, but you need to load the training data. Okay, so we are not going to create any training script this time, as we have done for other cases for tuning hyperparameter, batch inferencing, or real-time inferencing. In all those cases, we created a Python script to train our model, but here, since we are using automated machine learning using SDK, we are not going to create a Python script, training script for that. Okay, we'll just upload the data and use that data for automated machine learning. Okay, so here we are taking diabetes or diabetic patient data, okay, from CSV file, okay, to predict whether patients are diabetic or non-diabetic for individual patient, right? And we are creating a data set, okay, by uploading these two files and then converting it to tabular data set using this function dataset.tabular dot from delimited files, and these are comma separated values, right? Delimiter is the comma, and once the tabular data is created, okay, we will register that tabular data within our data set, which will show up here as an asset under the data set page. So I can open it, I'll show it to you. So if that data, same data is already present, it's not going to create all these things, it's not going to do all those steps. But if there's no data set with this name, right, this is the name, diabetes data set, then it is going to create that, okay, and then register it within our workspace so that it will show up in the data set page. So we do see diabetes data set is there, so it's going to skip, and this is a tabular data set, right? So it is going to skip this part of creating and registering within the workspace, and it will just print data ready, right? Data already registered and then data ready. So let's see that. Data already registered, right? And then we'll see data is ready. Now we are preparing a compute resource. Okay, within compute resource, we'll create a cluster to run our experiment. Okay, but this HP comp cluster is already present, so this is not going to create a cluster, but I will tell you what cluster is. This cluster will be used for training of our data, right? Of our experiment, and that cluster consists of a standard data science VM, okay, with 2 nodes, maximum 2 nodes, so it can go up to maximum 2 nodes, right? And that compute cluster will be a Docker based image created for our experiment, okay, and that cluster will be again registered within our workspace here, okay. So it will provision the compute cluster and then register it within our workspace, and that you can see under compute, and then in the compute you'll see that cluster name, okay. Now let's run this to create the cluster, but since the cluster is already present, so found existing cluster, use it, it will print, okay. So this one, right, because we already have a running cluster created, so it is just going to utilize that one. Now configure automated machine learning, okay. So this is here the automated machine learning part starts, okay. One of the most important configuration setting is the metric by which model performance should be evaluated. So here it is trying to print model matrices to evaluate the performance of the model, okay. So if we run it, AUC weighted, normal macro, macro recall, average precision score weighted, accuracy, all these matrices based on which the model will be evaluated. So these are all the attributes that will be set when we are going to run our experiment, and based on all these parameters we'll try to find out the optimal performance of our model, okay, a particular model which will be the optimal, okay, out of all the experiments that we are going to run with different algorithms, okay. Here this is a classification model that we are going to run, so that's why we are printing all the matrices related to classification, okay. Fine. Having decided the metric you want to optimize, AUC weighted, okay, you can configure the automated machine learning experiment, okay. To do this you will need an automated configuration or AutoML configuration. So we are importing that AutoML configuration from the same package that we checked whether this is part of our Python environment or not. It's being installed, this package installed or not, right? This is the first cell we check that, right? Azure ML train AutoML. From there, we are just calling or importing AutoML configuration. Okay, to run the automated machine learning. Now, what values it takes? Name of the experiment, which is AutoML experiment. What kind of algorithm we want? Classification problem that we are handling within this experiment. So we are mentioning the task as classification. Compute resource. The compute resource where this experiment will run. This we have already created like training cluster. And this is the same cluster we have named HP comp cluster, compute cluster, right? And then training data and test data is being sent here. And from where this training and test data is coming, you can check it from here. So this is where we uploaded the data, right? So from there we have test and training data, if you see here, right? 70 and 30%, and we are giving the seed as 1 2 3. That means it is going to randomize based on the seed value. Okay, and randomly split the data between 70 and 30%. Okay, and assign it to training data and test data. Okay, so that's what we are passing here. Then label or the column that we are going to predict is a diabetic or not non-diabetic, right, for a patient, and this diabetic column will be filled with the 0 or 1 based on diabetic and or non-diabetic and diabetic, right? How many iterations we want to run is the 4, like how many times this experiment will run for optimization, right? For AUC weighted, for different value of AUC weighted, it is going to optimize that value, right? And the number of nodes it can go is 2, maximum concurrent iteration, right? And featureization is auto because we are running automated email, automated ML machine learning, right? Now ready for the auto ML run. Let's run this. So it will just prepare auto ML configuration, and we have to pass this configuration to our experiment. Okay, so this configuration is prepared. Now if you see here, run an automated machine learning experiment. So in that experiment, what we are going to do, we are going to pass this run configuration. So here if you see, first we are creating an experiment. Okay, automated machine learning experiment, and where we will run within this workspace, and what would be the SDK that we are using, MS Learn Diabetes AutoML SDK. That's the SDK that we are going to use to run the automated machine learning. Now this is an experiment. Now within the experiment we will submit the configuration for the run. This is where we created the AutoML configuration. So an experiment will require a configuration based on which it is going to run. Provision the cluster, use that cluster, use the data, and run the iterations of our experiment. So that's a run configuration we have passed. Now this will show us the running status, okay, and give us the information about the run of our experiment. Okay, so let's run this. This is going to take some time, if you see here, because it's going to do all these, take all these steps for iterations, right? So I will pause the video, and once it's complete, we'll continue from there. Okay, now you see that automated machine learning experiment is running. It is showing the status as running. It's in the preparing section, so pipeline is being prepared. Then a job will be submitted as queue. So here you see the job has been submitted, and these are the experiments for automated SDK, right? and we can also see those in our notification, these experiments, MS Learn Diabetes ML SDK. That's what it is running right now. Okay, now the experiment is complete and we can see the statuses for each of these iterations, right? And all the duration that it took for each of these experiments. Okay, it is shown here. And if you go to AUC weighted, the plot is looking like this. You can check for other different parameters as well, right? Macro, micro, weighted, all these scores, okay, being run. Now, moving down, you can see the Azure Machine Learning Studio has run these different feature generation, right? Dataset featureization completed, model selection. So beginning model selection. Here it is running all these models. Class balancing detection, missing feature value imputation, high cardinality feature detection. All these checks were done on our data, right? Classes are balanced in your training data. No feature missing values are detected in the training data, and your inputs were analyzed and no high cardinality features were detected, right? High cardinality feature is done to find out the anomaly in our data, right? And missing feature value imputation is done to check whether any value is missing from our data, okay, either row or in columns, right? And class balancing detection to check the different classes that we are going to use for our production, okay. So all these things are there. Now the iteration being evaluated, pipeline, duration, metrics, and best score. So these are 5 P's that we are going to see here for our iterations. So we run 4 iterations, right? So maximum absolute scalar, light GBM, XGBoost classifier, voting ensemble, and stock ensemble. Okay, so these are different pipelines with different algorithms that we run, and we can see the best accuracy is for 9886, okay, and which is maximum absolute scalar light GBM, okay, for this algorithm or pipeline, okay. And these are all metadata of our run. You see weighted matrix. This was a automated machine learning experiment within this workspace. This within this region, compute target was this. All this information is related to metadata, okay, and these were the algorithms tried, okay. Supported models, whitelist models. There are still so many models, and then VM type that was used for our cluster to run our experiment, environment level, all these things, okay. So this is all just the logs, okay. So now we have completed our experiment, automated machine learning experiment. Now view the child runs, okay. So when the experiment is completed, view the output in the widget and click the run that produces the best result to see its details, okay. So check which run was the best, okay. So this is going to print all the logs. From each of the runs, okay. Now out of these runs, you can see all the matrices for each of these run IDs, right? These are different run IDs available for each of the experiments, okay. 1, 2, 3, 4, and 5. Okay, so total 5 runs that I showed you in the widget, right? Where is that? This one. Yeah, total 5 runs. 1, 2, 3, 4, 5. Right? Now, so 5 results. Okay. Now get the best run. So out of those, experiment. This will show us the best run. These are some warnings. The version of SDK doesn't match with the version the model was trained on. The consistency in the result may not be guaranteed. That's fine. These are just warnings. For now, we can ignore that. So best run transformation was data transformer pre-fitted soft voting classifier. Best run matrices with all these informations is shown here with this run ID. Okay, this is the run ID. This is the second one, right? Now, for this run ID, finally having found the best performing model, you can register it. So since we have got the best run ID information here, now we want to register this within the model section, and then we can utilize that model once it's registered within our workspace to run or utilize that model for the newer data. Okay, to predict new patients whether they are diabetic or non-diabetic. Okay, so let's do that, and we can see the latest diabetes model version is this with this much accuracy, and these are the AUC score. Okay, so if you see here, we have run this experiment a lot of times and registered our models, and if you see, out of all these diabetes model versions, the accuracy seems to be increasing. 89, here 89 almost, but somewhat lesser. 89, 88.7, 89, 94. It has increased to 94, and here we have 95 almost, right? 94.6 and 95%. So this is most accurate model that we have now, right? And we can use any of the model versions based on the version information, but if you define a model name while you are exposing this model as a service, and then you pass the data to this model, it will always take the latest model, okay, a latest version of the model, and that would be the most accurate version, right, to train your data or test the data and predict new patient whether they are diabetic or non-diabetic. So this was about registering the model within your workspace. Okay, so that's how we can do automated machine learning using the Azure ML SDK. Okay, so that's it for all for now. Please like and subscribe my video if you find this helpful. Thank you. Bye bye.